Hello, it's Dr. Sherman, and thank you for joining me for the last pre-lab introduction of the semester. This lab is torque and static equilibrium, and you're going to investigate forces at distances that cause rotation, or torque, and static rotational equilibrium using an online simulation. So you're going to apply forces to a rotating system and see how the distance from the axis of the rotation affects the torque, and also how the force affects the torque. You're also going to establish static equilibrium for multiple forces on the same rotational axis by balancing them. This is the last lab of the semester, and I wanted to thank you for joining me for the lab introductions and letting me facilitate your lab experience. A few notes to wrap up this semester. We do drop one quiz grade and one post-lab forum, but we do not drop any lab assignment grades, although we do accept late lab assignment. There is no discussion forum this week. I'll ask you to fill out the course evaluations in place of those, and I'll talk more about those later. For the first activity, you're going to investigate how changing a torque will affect a rotational system. So you're going to determine how the distance from the pivot point or fulcrum can affect a rotating system and how changing a mass could affect the rotating system. This lab does use a PhET simulation. Let's go ahead and open that up. That is called Balancing Act. It is in HTML, which means it can be used on multiple platforms. You'll notice there's 3 different versions of this particular simulation. We are using the Balance Lab version for activities 1 through 3. With that open, you'll notice it's a fairly straightforward simulation. We want to show the mass labels, the forces from objects, and also you might as well show the level. On the position menu, we do want to show the ruler. We're going to be taking bricks of a specified mass and putting them at a certain location, either to the left or the right of the pivot point based on the lab instructions. After you place the mass, you're going to then remove the supports from the level itself. If there is an unbalanced torque, it will rotate in one direction or another. So at minimum, show the mass labels, the forces from object, and the ruler. For activity 2, you're going to balance out a single torque. So you will place a 10 kilogram object 1 meter to the left of the pivot point, and you will calculate the location you would need to put a second mass to balance the meter stick and to achieve rotational equilibrium. Recall that static rotational equilibrium is defined as the sum of the torques equaling 0. So when you add all the different torques together, they must equal 0. Torque is of course defined as the perpendicular force times the distance from the axis of rotation, and a negative torque would cause the object to move in a clockwise rotation, and a positive torque would cause the object to move in a counterclockwise rotation. So for 2 forces acting on an object in static rotational equilibrium, you would consider that there's 2 different torques, so 2 forces, 2 perpendicular forces times 2 particular distances, and notice that one torque would have to cause positive rotation and the other would be negative rotation for them to balance out, which makes sense. If the forces we're talking about is the force due to gravity, or mg, and when the balance is level, those forces of gravity are of course going to be perpendicular to that ruler, we can solve for the location of a particular mass by considering the force of gravity times the first distance over the force of gravity of the second object. So looking at my simulation, if I place a 10 kilogram mass at 1 meter away, it seems pretty obvious that to balance that mass, I would have to put the second object to the left of the fulcrum. In the third activity, you're going to do much the same thing, except instead of balancing out one torque, you're going to balance 2 torques with a third torque, so balance out multiple torques. Of course, you're going to add those torques together, and the sum of all the torques should equal 0 because it's still in static rotational equilibrium. First thing to do is decide if the torques, the first two torques, will cause rotation that is in the positive or negative direction. So the first torque is going to be placed to the left of the pivot, so it's going to cause counterclockwise rotation. The second torque is going to be placed to the right of the pivot, so that will be clockwise rotation. You were told that the third mass needs to be placed also to the right of the pivot, and therefore it will also have clockwise rotation. So taking those signs of the torques into account, we can rephrase our sum of torques equation to have the first torque minus the second minus the third. You are solving for the mass, so you do your algebra correctly, and you should get the correct mass. For activity 4, we want you to play the balancing game. This game is really just to reinforce your basic knowledge of torque and rotation and try to have a little bit of fun. So open the game portion of the simulation. You're supposed to have fun, but you do have to complete the minimum requirements to get full credit for this activity. So the minimum requirement is to finish level 1 with 5 stars. So I believe that's answer a few questions and get them correct. I'd like to challenge you to see how many levels you can finish with 5 or more stars. In the end, you're going to submit a screenshot of the levels you have achieved. So here's an example, and one hint is you can't stop in the middle of a level. You have to complete the level to see your final score. So you can't do level 1 and then half of level 2 and get to this screen where you need to take a picture. So we tried to make a fun and kind of informative last lab for you, but nothing too taxing. Also, on that same vein, there is no post-lab discussion forum for this particular lab. Instead, we're going to ask you to fill out the course evaluations. One thing you should know is that the evaluations aren't quite open the same time that you may finish the lab, but you will get an email for when those are available to you. In these evaluations, you will have course-specific questions and instructor-specific questions. For your instructor, you're going to be evaluating the lab instructor that was assigned to your particular section. So the person you have been emailing back and forth for the most part. For the course-specific questions, I would really like to hear your opinion on the structure of the lab course and the individual labs themselves. So please tell me, did the lab course go better than you expected or worse than you expected? What helped you? What could I provide that would really help you in the future? Keep in mind that what you write for this lab course is not shared with your lecture instructor and vice versa, so please only address the lab in your comments to me and your lab instructor, and the lecture in your comments to your lecture instructor. Thank you, and as always, have a great week.